This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on product to sum identities. So here's a first collection of identities. Sine alpha, sine beta is 1/2 cos alpha minus beta minus cos alpha plus beta. Cos alpha cos beta is 1/2 cos alpha minus beta plus cos alpha plus beta. And sine alpha cos beta is 1/2 sine alpha plus beta plus sine alpha minus beta. And we just need to get some practice in terms of how to use these. So there it is, and I'm interested in sine 7x, sine 2x. So we have to decide which identity to use. Using the first one, replacing alpha with 7x and beta with 2x. That gives me 1/2 cosine alpha minus beta, 7x minus 2x, minus cos alpha plus beta, 7x plus 2x. Then simplifying that, you see we get 7x minus 2x is 5x. 7x plus 2x is 9x. So we get sine 7x, sine 2x is 1/2 cos 5x minus cos 9x. They don't look like they would be the same, but in fact they are. Let's look at another example. We have cos 8x, cos 5x. So looking at this, which identity should we use? Second one, alpha is 8x, beta is 5x. So it should be 1/2 cos 8x minus 5x plus cos 8x plus 5x, as you can see here. And then 8x minus 5x is 3x. 8x plus 5x is 13x. And we have cos 8x, cos 5x is equivalent to this. This becomes important in calculus because it's difficult to work with this kind of function, easier to work with that kind of function. Let's look at another example. If I have sine 7x, sine 2x, which formula do I want to use? First one, sine alpha, sine beta. Alpha is 7x, beta is 2x. So we see cos 7x minus 2x minus cos 7x plus 2x, which of course becomes 1/2 cos 5x minus cos 9x. So again, not too difficult for us to use. If I have sine 9x cos 3x, now we're using this version. So that's 1/2 sine alpha plus beta plus sine alpha minus beta. Alpha would be 9x, beta would be 3x. 1/2 sine 9x plus 3x plus sine 9x minus 3x. 9x plus 3x is 12x, 9x minus 3x is 6x. And we get that. If I have sine 2x cos 8x, this one is going to be just a little bit harder. Alpha is 2x and beta is 8x. So replacing that, we'll get sine 2x plus 8x. Fine, that'll be sine 10x. But then sine 2x minus 8x, and this is the first time we've seen a negative number appearing in our discussion. So 2x minus 8x is negative 6x. And then we have to remind ourselves, how does sine behave? Sine is an odd function. Sine of negative theta is negative sine theta. So knowing that, sine of negative 6x is the same as negative sine 6x. So this would replace with minus sine 6x using the fact that sine is an odd function. Remember, cosine is an even function. Cosine of negative theta is cos theta, so if that comes up, you can keep that in mind as well. So making the substitution, sine of negative 6x just becomes negative sine 6x, and we have sine 2x cos x written in an equivalent form. So we use those three identities to look at all of those examples. We've got a few more identities to work with, and these are pretty complicated, so you just have to practice with them. Recognize whatever you plug in for alpha here becomes alpha over there, whatever you plug in for beta there becomes beta over there. That's our idea. So I want to look at sine of 7x plus sine of 3x, which is going to require me to look at this first example. Alpha is 7x, beta is 3x. That'll be 2 sine 7x plus 3x over 2, cos 7x minus 3x over 2. 7x plus 3x, 10x over 2, 5x. 7x minus 3x, 4x over 2, 2x. And we have rewritten sine of 7x plus sine of 3x. This sum is now written as a product. Continuing, if I have cos 6x minus cos 2x, which formula to use? This fourth one, alpha will be 6x, beta will be 2x. So we'll get negative 2 sine alpha plus beta 6x plus 2x over 2 sine alpha minus beta 6x minus 2x over 2. 6x plus 2x, 8x over 2 is 4x. 6x minus 2x, 4x over 2 would be 2x. And sure enough, that's what we get. So another equivalent representation, cos 6x minus cos 2x is negative 2 sine 4x sine 2x. Now what is this good for? Why do we spend all this time working with product sum identities? In calculus, it's terribly important because certain functions are difficult to work with, others are easy to work with. We need to be able to convert between them. So let's look at an equation. How are we going to solve sine of 5x plus sine of x equals 0? We're going to want to write that as a product, because if a product equals 0, one of the factors must equal 0. So which formula are we going to use? Well, here's two of the formulas we looked at previously. And the one we're going to want is sine of alpha plus sine of beta equals 2 sine alpha plus beta over 2 cosine alpha minus beta over 2. Alpha here will be 5x, beta will be x. 2 sine 5x plus x over 2 cos 5x minus x over 2. So 5x plus x, 6x over 2 will be 3x. 5x minus x, 4x over 2 will be 2x. So that's what we get. And our original equation asked us to set that equal to 0. If this equals 0, then this product equals 0. And you see, if the product equals 0, we have an advantage, because if the product equals 0, one of these factors must be 0. 2 can't be 0. So either sine 3x will be 0 or cos 2x will be 0. So again, here was our original question. We're looking for the values between 0 and 2 pi that will satisfy the conditions of that equation. Well, we said in terms of our product of sum identities that sine of 5x plus sine x was simply 2 sine 3x cos 2x. So if I set this equal to 0, then 2 sine 3x cos 2x has to equal 0. 2 can't be 0, so either sine 3x is 0 or cos 2x is 0. Now when is sine 0? Sine is 0, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, etc. But I've got to go 3 rotations, 3 revolutions. This 3x indicates that. So the first revolution, 0 and pi. Second revolution, 2 pi and 3 pi. Third revolution, 4 pi and 5 pi. So what I'm going to say is 3x is these 6 numbers that correspond to our 3 revolutions. So next I've got to divide everything by 3. So if I divide all those guys by 3, x then is 0 over 3, pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Of course, 0 divided by 3 is 0, and 3 pi divided by 3 is pi. So we can get the solutions to the first phase of our problem. When does sine 3x equal 0? When x is 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. Now looking at this one, cosine of 2x is 0. So when is cosine 0? And I'll need 2 revolutions. Cosine is 0 at pi over 2, 3 pi over 2. Then at pi over 2 plus 2 pi. And at 3 pi over 2 plus 2 pi. So what are those values? Pi over 2 plus 2 pi is 5 pi over 2. 3 pi over 2 plus 2 pi is 7 pi over 2. Now we have to divide each one of those by 2. Dividing by 2 is the same as multiplying by a half. So pi over 2 times a half is pi over 4. 3 pi over 2 times a half is 3 pi over 4. 5 pi over 2 times a half. 5 pi over 4, 7 pi over 2 times a half, 7 pi over 4. Multiplying both sides by a half, we get those 4 answers. Now, how many do we have all together in the first period as x ranges from 0 to 2 pi? 1, 2, 3, 4, 5, 6 answers there. 1, 2, 3, 4 answers there. So in total, there are 10 solutions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 solutions to that original equation, sine 5x plus sine x equals 0 when x is between 0 and 2 pi. And that will conclude this lesson.